CloudHub architecture. Here you can see CloudHub architecture. MuleSoft defined the CloudHub as a cloud-based integration platform as a service, IPaaS, that enable developers to integrate and orchestrate applications and services while giving operations and control and visibility they required for mission critical demands, all without the need to install or manage middleware or hardware infrastructure. You can deploy applications to CloudHub through any point through Anypoint Runtime Manager found on the Anypoint platform. Comparing CloudHub with other app deployment scenarios, Runtime Fabric, customer hosted, private cloud foundry. It is the easiest option for deploying Mule applications. However, the applications CloudHub as itself and Mule applications are deployed, executed under AWS infrastructure. For example, and specifically each deployed application is running under EC2 instance with the Linux or Mule runtime with JVM. How each instance per work is more complex than it may seem. CloudHub workers also execute cloud-based system services on the OS. And Mule runtime, which are required for the platform capabilities provided by CloudHub, such as monitoring of Mule application in terms of CPU, memory usage, number of messages, errors, etc., which allow Anypoint platform to provide analytics and alerts based on the matrices. Auto restarting failed CloudHub workers, including failed Mule runtime and on the otherwise functional EC2 instances. Load balancing only to healthy CloudHub workers. Provisioning of new CloudHub workers to increase or reduce capacity. Persistence using object stores of message payloads or other data across the CloudHub workers of a Mule application. DNS entries for CloudHub workers on and CloudHub load balancer. Each Mule application is assigned a DNS name maintained by the AWS root. Here AWS platform services are connected to naming, persistence, load balancing, and AWS platform services interacts with the provisioning and auto start. Here the persistent is connected persistence, provisioning, load balancing, and auto start are connected to HA and scalable execution. It interacts with the CloudHub worker. Here the auto restart is connected to CloudHub auto restart, and load balancings are connected to CloudHub system services in CloudHub worker. Here the monitoring and alerting of API implementations is connected to CloudHub system services in CloudHub worker. CloudHub system services, Mule runtime, Linux, and policy holder search implementation are in CloudHub worker. Here the CloudHub system services are connected to Linux, and here the CloudHub system services are connected to interact with Mule runtime, and Mule runtime interact with the Linux. Here the backend system interacts with the Mule runtime, and policy holder search implementation. Here the fault tolerant API invocation interacts with the Mule runtime and policy holder search implementation. Policy holder search RAML definition is in policy holder search implementation. Now this is the end of my presentation. Thank you very much for watching it.